Hi there, folks. This is the review for solving quadratics, and as always, I am the amazing Mr. Jansen. So here we go. If we take a look at this first one, this first guy, we're asked to find each value in graph, and this one's in vertex form. Remember, vertex form is y equals a times x minus h squared plus k, where hk is our vertex. Okay. And so for this one, when we look at this, because it's x minus h, we always kind of take the opposite of this guy. So right here, my h value is a -2. My k value is right here. It's a +2. That one we read just as it is. The axis of symmetry is always x equals the x value from the vertex, so it's x equals -2. And again, it has to be x equals because it's the equation of a vertical line. The y-intercept, for any equation, the y-intercept is when we plug a 0 in for x. So if I plug a 0 in for x here, I'm just going to see what I get. I get y equals a -1/2. That's going to be 2 squared plus 2. That's a -1/2 times 4 plus 2. So I've got a -2 plus 2, which is 0. So my y-intercept, I plugged a 0 in for x. I got a 0 out for y, so it's the ordered pair 0, 0. For the x-intercept, well, if the y-intercept is when I plug a 0 in for x, algebraically, the x-intercept is when I plug a 0 in for y. So if I plug a 0 in for y, I essentially get this. Okay, so I set this equation equal to 0, and I just have to solve. And this is set up to solve using my square root. I subtract the 2 from each side, so I end up with a -1/2 x plus 2 squared equals a -2. I multiply each side by a -2, or by a -2. So I get x plus 2 squared equals 4. I take the square root of each side. And just remember, whenever I take the square root of each side of an equation, I have to do plus or minus that value. And then I subtract the 2. So what I find out is that I've got x equals, I've got a -2 and I've got a plus or minus 2. If I do -2 plus 2, it gives me a 0. If I do -2 minus 2, it gives me a -4. So I get 2 separate answers here. And I could express those as ordered pairs, a -4, 0, and a 0, 0, which is no surprise because that y-intercept has to also be an x-intercept. It crosses each of those axes. And so now as I plug this stuff in, first of all, let's look back at the a value. The a value is negative, which means this thing is going to open up. I'm sorry, open down, which means our vertex is a maximum. So I just plot everything. -2, 2 is right here. The axis of symmetry I graph as a dotted line. I can plot some of these other points. The 0, 0, that's my y-intercept. The -4, 0 is my other x-intercept. So this is enough information to graph. I draw the best curve I can draw. Okay. I can also use that a value to help me. This thing should have been shrunk vertically, and it is. It's wider than a normal parabola. Okay. For this one, keep in mind that f of x, this is the same thing as saying y equals x squared plus 4x minus 5. And this one's in standard form, so to find the vertex, I have to do the opposite of b over 2a. The opposite of b is a -4 over 2 times a, which is 1. So it's a -4 over 2, which is a -2. So that's the x value for my vertex. To find the y value, I just plug that in. So -2 squared plus 4 times a -2 minus 5. So that's 4 minus 8 minus 5, which is a -4 minus 5. So I get a -9. Axis of symmetry is always x equals the x value from the vertex. The y-intercept, I plug a 0 in for x. Also in standard form, it's always the c value. It's always the constant term. When I plug that 0 in, I get a -5. So again, that's the order pair 0, -5, 0 in for x, -5 out for y. And then the x-intercepts, I plug a 0 in for y again. So this is going to be an x squared plus 4x minus 5 equals 0. And I solve. I'm going to solve this one by factoring. I build a bridge. Two numbers that multiply to a -5 but add to a +4 are a 5 and a -1. I can use my shortcut, so that's an x plus 5 and an x minus 1. And then I set each factor equal to 0. So I find out that x equals a -5, and x equals a positive 1 when I finish solving those. And again, as ordered pairs, it's a negative 5, 0, and it's a 1, 0. This one's got a positive a value, so it opens up, which means my vertex is a minimum. And as I go to graph this thing, negative 2, negative 9, let's see, 1, 2, 3, 4, 5, 6. I'll just extend the graph, 7, 8, 9. You can rescale the graph. You can go by 2s or something like that. I'm just going to rescale it. So negative 2, negative 9 is right around here. The y-intercept of negative 5 is right here. I've got my axis of symmetry. Let me draw that. My axis of symmetry allows me to reflect that y-intercept that I just graphed. The x-intercepts at negative 5 is right here, and a positive 1 is right here. Again, those are reflections of one another, and that's plenty of information for me to graph this thing. So I draw the best parabola that I can draw. Okay? For the next one, it's very similar. This is in standard form, so to find my vertex, I do the opposite of b over 2a, so that's a negative 2 over 2 times a negative 1 this time. So that's a negative 2 over negative 2, which is a positive 1. That's the x value for my vertex. The y value for my vertex, I have to plug that one in. Keep in mind this is a negative and then 1 squared plus 2 times 1. Be careful when you're plugging this in, especially with that negative out front. It's 1 squared, which is 1. Now I tack on that negative sign. So that's going to be a 1 plus 4, which is 5. The axis of symmetry is always x equals the x value from the vertex. The y-intercept, once again, I plug a 0 in for x. So if I have a 0 squared plus 2 times 0 plus 4, again, it's just the constant term. It's the c value, and that's the ordered pair 0, 4, 0 for x, 4 out for y. The x-intercepts are going to be a negative x squared plus 2x plus 4. I plug a 0 in for y. So I set this equal to 0. And if I'm trying to solve this, the first thing I'm probably going to do is divide each side by a negative 1. Just because I want a 1 out front, I want to see if I can factor this thing. Plus, dealing with a negative out front is always a little bit of a pain. So I get rid of that negative. Now I can build a bridge. Two numbers that multiply to a negative 4 but add to a negative 2. I can't think of any, so that's not going to happen, which means I have to either do completing the square or my quadratic formula. I'm going to complete the square. I'm going to add the 4 to each side. So when I do that, I get an x squared minus 2x equals 4. I've created space, and now I fill in the blank. I do b divided by 2 and square it. Again, if I take that off to the side, negative 2 divided by 2 and square it, I take that middle term. That's a negative 1 squared, which is 1. So I add a 1 right here. Whatever I do to one side, I have to do to the other side. And so that's going to give me an x squared. Sorry, I'm going to factor this. That's going to give me an x minus 1 squared equals 5. And now from here, I take the square root of each side. So I find out that the x minus 1 equals plus or minus the square root of 5. And then I add the 1. So my exact solutions for this one are going to be x equals 1 plus or minus the square root of 5, which literally means 1 plus the square root of 5 and then 1 minus the square root of 5. But then if I want to express this thing on the graph, those numbers don't really help me. I maybe want to plug those into my calculator. Again, I'm going to write this twice over here, but my two x-intercepts are the 1 plus root 5 and the 1 minus root 5. If I plug those into my calculator, when I do 1 plus root 5, I get a 3.24. And when I do the 1 minus, I get a negative 1.24. So really, when I'm graphing these, I probably want to think of these as like a 3.24, comma 0, and then a negative 1.24, comma 0. Because that's what's really helpful when I'm graphing this. If you have this written down as 1 plus or minus the square root of 5, that's absolutely an acceptable answer. I just want something that's going to help me graph. The a value is negative, which means this thing opens down, which means I have a maximum on my hands. And now as I plot these things, 1, 5 is right here. My axis of symmetry is right here. My y-intercept at 4 is right here. I can reflect that point over here. My x-intercepts, and this is why I wrote these as decimals, 3.24 is right around in here somewhere. and a negative 1.24 is right around here. And I can see that those are symmetrical. They're reflections of one another. So now I know I'm on the right track. And I draw my parabola. Okay? For these, I just want the number and type of solution, so I'm just going to use the discriminant. So I do the b squared minus 4ac. Again, I'm using the discriminant b squared minus 4ac for these, because my discriminant will tell me what kind of solutions I have. So when I do that, that's going to be a negative 2 squared minus 4 times a, which is 3, times c, which is 7. When I plug that in, I get 4 minus, let's see, 4 times 7 is a 28, times 3 is an 84. So you get a negative 80. If the discriminant is negative, I know I have two complex solutions. Okay, that's what it means when I get a negative under the square root. For the next one, I do the b squared minus 4 times a, which is 1, times c, which is 16. So I end up with a 64 minus 64, which is 0. When the discriminant is 0, it means I have one rational solution, because again, it takes away that plus or minus effect, so I'm left with one thing. For number 6, when I plug this in, I do 7 squared minus 4 times a, which is a negative 2, times c, which is a negative 6. When I plug this in, I get a 49, and then I get, let's see, a 12, a positive 12 times 4. It's going to be a minus 48, it looks like. And that gives me a positive 1. And positive 1 is a perfect square. When I have a perfect square, that means I have two rational solutions, because I can take the square root of that thing and actually do the addition and subtraction, and then the division. And then for the last one, I do the 8 squared minus 4 times a, which is 1, times c, which is 5. So that's going to give me a 64 minus 20, which is a 44. That's a positive number that's not a perfect square, which means I'm going to have two irrational solutions, because when I do my quadratic formula, or when I do completing the square, I'm going to be left with a square root. Okay? For these, I want to complete the square and then factor. So for completing the square, I just do b divided by 2 and square it. So again, here I'm doing 6 divided by 2 and square it, which is a 3 squared, which is 9. So my missing term here is a plus 9. And then if I want this in factored form, it's x plus 3 squared. And again, the shortcut is just taking the thing that I squared here. It's the b value divided by 2. For number 9, I want to leave this as a fraction, but I do b divided by 2 and square it, which is going to give me a 25 over 4. So that's what I'm looking for here, is the plus 25 over 4. And then if I want to write this in factored form, again, it's always x, the b value divided by 2, which is a plus 5 halves squared. In number 10, again, b divided by 2 and square it. So I take the negative 8 divided by 2 and square it. That's a negative 4 squared, which is a positive 16. So this is going to be a plus 16. And then the factored form, once again, is x. B value divided by 2 is minus 4 squared. And then the last one here, it's the negative 3 divided by 2 and square it. Negative 3 squared is a 9. 2 squared is a 4. So it's a plus 9/4 here. And then once again, my factored form is x. B value divided by 2 is a negative 3 halves squared. And that's it.